Okay, this is the lesson 7.4. We're starting the matrix properties and operations. And I'm going to show you how to add, subtract, and multiply matrices and how to use your calculator to do that. Okay, so matrices are just rows and columns of numbers. Okay, and they're classified by their dimensions. And we always go by the number of rows first and then the columns. So it's rows, then columns. Okay, so this matrix that they have here with these 6 numbers, it has 2 rows and 3 columns, so it's a 2 by 3 matrix. Okay, so always goes by the rows first and then the columns. So this is a 2 by 3, not the other way around, not a 3 by 2. A square matrix, as the name implies, has the same number of rows and columns, makes a square. Okay, so find the dimensions of each of these matrices. Okay, so not too tough. So this first one, how many rows does this first one have? Well, if we look at it, it has one, 2, 3 rows. Okay, so how many columns does it have? 1, 2 columns. So the dimensions on this one are, it's a 3 by 2. And if we want to refer to the specific place on a matrix, sometimes you see it like this. The 6 is in the 1, 1 spot. The 5 would be in the 1, 2. The 6, 3 would be, and we always go the rows first. The 2, 1, 2, 2, 3, 1, 3, 2, like that. Sometimes you see them referred to specific numbers that way as the kind of the coordinates of where they are in the matrix. Okay, so this next matrix here, the next example looks pretty square, same number of columns, same number of rows, so it's of course going to be a 3 by 3 square matrix. This is also a matrix down here, this bottom one, even though it looks just like a row of numbers. How many rows does it have? How many columns does it have? It has 1 row and 5 columns, so it's a 1 by 5 matrix. Okay, examples, if these two matrices are equal, find the values of x, y, p, and q such that they're equal. Okay, so if they're equal, that means all the corresponding values are going to be the same. Okay, so this is not too tough if you understand what they mean by the corresponding values. Okay, so the 2 in the matrix A is this corresponds to the same place in matrix B. The 1 corresponds to the Y, and the same thing for the Q and the 0, right? So they correspond to those. The same numbers in the same place have to have the same values. So X is going to equal 2, Y is 1, P is -1, and Q is 0. Okay, so not too tough. Okay, so adding matrices. Okay, so the sum of two matrices, if when we add them up, we add up the corresponding numbers that are in the same place in each matrices. Okay, so we can only do this, it only works with the sum, and subtraction too only works if the matrices have the same dimensions. Okay, so they have 2 by 2 matrices here. So we're going to add the 5 and the 4, and we're going to get a corresponding matrix, a 2 by 2 matrix, as our answer. So 5 and 4 is 1, 6, -6 and 6 is 0, 8 and 8 is 16, 9 and 3, -3 is 6. So adding those two together gives us a new matrix with the corresponding numbers added up. Okay, so A and B on the second example, example B, they have a matrix that's a 2 by 2, and this one is a 2 by 3. Okay, if we're trying to add these up, can't do it. We need to have the matrices be the same dimensions to add or subtract their matrices. Okay, so analytic solution, do it like I said. So it's not too hard when you have a small matrix like 2 by 2s to do it. And they say the graph and calculator solutions down here. And I want to show you how to do these matrices on your calculators. And there's 2 ways to do it. It depends on which operating system you have. And I'll show you both ways quickly here on this example here they give us. Okay, so the first way to do it, the way they explain here in the book, has us using the matrix menus from the calculator. Let me get out of this. Okay, and discard that. Start my calculator up here. Okay, so on the matrix menu, it's right on the F minus 1 there. So I'd go second, matrix menu, and I get this whole matrix menu. And if I wanted to define a matrix, one way to do it is to go over here to the edit, and I'm going to say, okay, matrix A, what's the dimensions of matrix A? And so I just wanted to do the simple one. So I would put in 2, enter, and then 2, enter, and then it drops down here to the coordinates are right here. See, it says 1, it says 1, 1. This is my first row, first number right here. And it shows where it is on in black there. So I'm just going to say, okay, so matrix A is just the same thing they had in the book. So -5, I'll put enter, it jumps over automatically, 6, enter, and it goes down to enter 4, enter. Okay, so now I have my matrix A defined as with these numbers, 2 by 2 defined as this one. Okay, so if I want to go back to the matrix menu, and I want to edit, and I want to do the same thing for matrix B. Okay, so let me get rid of my smart ink there. Okay, so I want to do this a 2 by 2 also. So I just hit 2 by 2 and enter, and then I hit the numbers I want to put in there, which are -4, 6, 8, and -3. Okay, so if I want to add these two matrices up, I get out of here, so I have my two matrices that I had added up. Go to the matrix menu, and it tells me here that, okay, I've defined these two matrices A and B. You can hit enter, and then you do plus, second matrix, hit B, A plus B, and it gives us these numbers added up. I can also do the same thing with subtraction. I can do the second matrix. I can do A minus matrix B, get the answers. And if I do B minus A, of course, I'm going to get different answers. I won't get different answers if I do B plus A, but I'll get the same, I get different answers if I do B minus A. Okay, so different answers, right? The inverse answers, actually. So that's one way to do the matrices on your calculator. I'm going to clear this off and show you guys another way to do it. If you have the Math Print operating system, if you probably forgot about this, but if you hit the alpha key and the zoom button, it comes up here and this little matrix menu comes up. Okay, so we can go ahead and define, a 2 by 2 matrix. Okay, and then it actually pops up here on the screen. And then we could just fill in whatever numbers we want. I'll just make some up at random. I'll do 1, 2, go down over here, put 3 and 4 in here. Okay, so that's my matrix. I can do the same thing if I want to add or subtract another one. So I just do format. I just want to do another 2 by 2. If I want to do another 2 by 2, just leave it the same way. Put in those numbers, and I'll just keep going. 5, 6, and you guessed it, 7 and 8. Okay, what I forgot to put in here, I wanted to put my operation in between. So I should put second insert plus. I should have put the plus in there in between, and it gives me the answers adding those two up. Okay, so that's another way to do the matrices. Remember, it's the alpha and the zoom key. It gives you the matrix. You can define your matrices right on the screen. You don't have to go to any of those other menus, and you can do the operations right on the menus like that. So if your calculator doesn't have the operating system on it. See me, I'll transfer this math is called math print operating system on there, and you can enjoy the benefits of that. Okay, so we'll get out of this for a second, go back to the slideshow here, and okay, so we know how to add and subtract with our calculator. So I'm not going to, and if the dimensions aren't the same, like on A and B here, if A and B are not the same, then they're not going to work. Well, for adding and subtracting, you have to have the same dimensions. Zero matrix, no surprise, has all zeros in it. And if we add two matrices together and the sum comes up to the zero matrix, then they're called the additive inverses of each other. Okay, so additive inverses means that they add up to zero. Okay, yeah, then this is the same dimension, same thing with the subtraction. It's the same. Subtracting two matrices is the same as adding a negative one. It doesn't make any difference there. I'm going to go quickly on that one. Is added to itself. What I want to talk about on this slide is the scalar deal. Okay, so if we add two things up, we get two matrices, get double the fun, right? The two matrices, they get double that. So if we put a number in front of it like this, that means that this is our scalar number. That number I've circled in red is the scalar number. It scales the matrix up or down. It doesn't have to be an integer number. It can be any number we want. And we actually multiply all the elements in the matrix by this number that's outside of it. So this 2 times each one would be 4, 10, 2, 6, 8, and 12. These two, I'm going to outline in red, are exactly equal to each other. And that's what the equal sign means. So the scalar thing is just multiplying each element in the matrix by whatever number is outside of it. And it doesn't have to be an integer, but most of the time we do that. And so if you have a little example here, we just multiply all these elements by 5, and we get 10, negative 15, 0, and 20, right? No problem. And you can do this if it's a if it's bigger than 2 by 2, you may want to put it in your calculator, but it's really not too hard to do it by hand, this one. Okay, matrix multiplication is a little different. Okay, the product AB of an M by N matrix A and a N by K matrix is found as the follows. Okay, so blah, 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 blah. Okay, so that was back in the day, right? Back when I was doing it, we learned this in college, and you had to go through this and add this and add that, and it was like tedious and boring. Okay, so we're going to skip all that and just use our calculators to do this. I would no more expect you guys to multiply two matrices together that were, any more than a 2 by 2 than I would expect you to do the square root of, 1138. Okay, so we use our calculators to do square roots. We can use our calculators to do these matrix multiplications. It just makes sense. Use the tools we have at hand. Common tools now for these math problems. It takes the tediousness out of doing these multiplications. Okay, but the main thing here I want you to get on this slide is not the blue part, but if the number of columns and the number of rows is the same. I'll show you what I mean by that. Okay, so the product of AB of the two matrices. So this matrix A is a 2 by 3 matrix, right? 2 rows, 3 columns. Column and B is a 3 by 2 matrix, right? It has 3 rows and 2 columns. You can only multiply matrices together if these two numbers, this column number and this row number, are equal. So the columns have to equal the rows. And then the product, your answer, the matrix you get is going to be a 2 by 2. Okay, so this gives you it ends up being a 2 by 2 matrix. So these kind of ones in the middle, the way the rules work is they cancel out and you end up getting a 2 by 2 matrix. Okay, so they have to, when you're trying to multiply these together, you have to have the columns in the first one equal the rows in the second one, and then the dimensions of the matrix you get it as the product are whatever the rows were and the columns here. So this is the rows of the first one, and the columns of the second one. Okay, so keep that in mind when you're doing these matrix multiplication. The columns in the middle cancel out, and you get the rows and columns on the end. All right, has to be that way for matrix multiplication to work. Okay, so this is all the tedious stuff I had to do way back in the day. All these numbers, blah, 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 blah. Okay, so we're not going to use the graphing calculator to find the products. Okay, so yeah, all right, graphing calculator, good job. So let's use our graphing calculator to find these two products. Okay, so we're not going to go through all the tedious steps they had in there. So let's just mention so I can find it. Okay, so I got it. No, discard that. Start my calculator again. Okay, so to multiply two matrices, get on clear this. And I want to start first one I want to do is I want to do a 2 by 3 matrix. Okay, so I say okay. Pops up with a 2 by 3 matrix. I'll put in my numbers for these two matrices. -3 here. I'll go down, put 5 over here, 4, 0. And over here, I'm using the 2, 4, 2, and 4. Okay, so I'll get out of the matrix here. What do I want to do with this matrix? I want to multiply it. What do I want to multiply it by? Hit the alpha key in the zoom, and I want to multiply it by a 3 by 2 matrix. Okay, it has to be the rows, the columns of the first one have to equal the rows of the second one. Okay, so I'm going to put this as examples. I'm just doing the ones they have in the book. 3, 2. Populate this one. 4, 3, and -2. Okay, so get out of there, hit enter, and the calculator does all the work for you. Now that's the answer. It's a 2 by 2 matrix that is already done for you, right? So that's multiplying matrices. Okay, so pretty easy stuff. It's a lot easier, and we're going to show you guys how to use these multiplying these matrices to solve systems of equations here in the next video. But for right now, answer the questions on the form below, and I'll see you guys in class tomorrow.